3D printing, also known as additive manufacturing, encompasses a variety of technologies that build three-dimensional objects layer by layer from a digital design. These technologies differ primarily in the materials they use and how they deposit and solidify those materials. Here are the main types of 3D printers, categorized by their underlying technology. 1. Material extrusion, FDM-FFF. Fused deposition modeling, FDM, or fused filament fabrication, FFF. This is by far the most common and accessible type of 3D printer, especially for hobbyists and consumer-level use. How it works. A thermoplastic filament, like PLA, ABS, PETG, is fed through a heated nozzle, melting the plastic. The printer then extrudes this molten plastic layer by layer onto a build platform, where it solidifies. Pros: relatively inexpensive, wide range of materials, easy to use, good for prototyping and functional parts. Cons: visible layer lines, lower accuracy and surface finish compared to resin printers, can struggle with fine details or complex geometries without support structures. 2. Vat photopolymerization. These printers use a liquid photopolymer resin that hardens when exposed to a specific light source. Stereolithography, SLA. One of the oldest 3D printing technologies. How it works. A UV laser traces the shape of each layer onto a vat of liquid photopolymer resin, curing and solidifying it. The build platform then moves down, and the next layer is traced. Pros: high accuracy, smooth surface finish, capable of intricate details, good for prototypes, molds, and dental applications. Cons: slower than DLP. LCD, limited material options, resins can be brittle, requires post-curing and cleaning. Digital light processing, DLP. Similar to SLA but faster. How it works. Instead of a laser, a digital light projector flashes an entire layer's image at once onto the resin, curing it significantly faster than a single laser point. Pros: very fast print speeds, especially for larger objects. High resolution, smooth surface finish. Cons: similar material limitations to SLA, requires post-curing and cleaning. Liquid crystal display, LCD. Masked stereolithography, MSLA. A more recent and often more affordable version of vat polymerization. How it works. Uses an LCD screen as a mask to control where a UV LED array cures the resin. The entire layer is exposed simultaneously, similar to DLP. Pros: affordable, good resolution, relatively fast. Cons: LCD screens have a limited lifespan, similar post-processing to SLA DLP. 3. Powder bed fusion. These technologies use a high-energy source to fuse powdered material layer by layer. Selective laser sintering, SLS. How it works. A high-power laser selectively sinters, fuses small particles of polymer powder, e.g. nylon, in a heated build chamber. The unfused powder acts as a natural support, eliminating the need for dedicated support structures. Pros: produces strong, functional parts with good mechanical properties. Excellent for complex geometries, no support structures needed. Cons: parts have a slightly rough, porous surface finish, limited material options, mostly nylon-based, can be expensive. Selective laser melting, SLM. Direct metal laser sintering, DMLS. These are specifically for metal powders. How it works. A laser fully melts fine metal powders, e.g. a stainless steel, titanium, aluminum, layer by layer, creating fully dense metal parts. Produces highly functional and strong metal parts, ideal for aerospace, medical implants, and industrial tooling. Cons: very expensive machines and materials, complex process, requires specialized facilities and post-processing. Electron beam melting, EBM. Another metal 3D printing technology. How it works. Uses an electron beam in a vacuum chamber to melt metal powder, similar to SLM DMLS. Pros: good for certain reactive metals like titanium, can produce very strong parts. Cons: high cost, limited material selection. Multi-jet fusion, MJF, developed by HP. How it works. An inkjet array applies fusing and detailing agents to a bed of polymer powder, and then a heating element passes over to fuse each layer. Miles very fast, produces parts with consistent mechanical properties and good surface finish. excellent for functional prototypes and end-use parts. Cons primarily uses nylon, limited color options. 4. Material jetting. How it works. Functions similarly to an inkjet printer, but instead of ink, it jets droplets of photopolymer material, or sometimes wax, onto a build platform. A UV light then cures the droplets. Pros. Can print multi-material and multicolor parts in a single print. Very high resolution and smooth surface finish. Good for highly detailed prototypes and models. Cons: materials can be more brittle, often higher cost.